Hello, everyone, and welcome to the ARC webinar. My name is Thomas, and I'm going to co-host the event today with Darren. We're going to present you ARC as we are rolling out ARC into public beta. ARC is the open source transaction processor commissioned by BA to replace mAPI. This open source version has been developed by Simon Ordish and Sigi Orkason, and now the current open source roadmap is taken care of by the TAL team, specifically Michael Buckley, Shota Silagadze, and Farzan Fatemifa. In terms of stage of development, so we're going to cover the different milestones of ARC. ARC is currently run by TAL and Gorilla Pool. And the goal of today is to first present you ARC, what are the different features, the advantages of ARC, but also to explain you specifically how ARC is different from mAPI. We are going to touch on the ARC roadmap, and the goal of today is to make sure that we improve transparency within the ecosystem to provide you with more visibility about the upcoming infrastructure changes. So don't hesitate to interrupt us. I'm going to hand it over to Darren, who is going to walk you through all the different items that I just explained before. Hand it over to you, Darren.
Thanks, Thomas. Welcome everyone. Thanks for joining. We're going to start with what is a transaction processing service, just in more general terms, because I think that will help clarify a lot of the decisions that were made over the last year in developing this particular solution. So first of all, the BSV node network is a peer-to-peer network. Now, those tend to be pretty messy things. They're very, very robust. And the idea is that nodes can come and go as they please. So you can't necessarily rely on a particular node in this network to always be available. And it's difficult to tell who's who. And the communication is really on a best effort basis. So it goes for transaction propagation. It goes for block announcements. And often what happens is a node will announce that it has a particular piece of information, some data, and the other nodes will then request a data message to be sent to them if they don't have that data already. And using that process, we very quickly arrive at a sort of global network consensus. So this all happens within about 2 seconds, but it's definitely a messy process and would be pretty difficult to handle that from something like a mobile connection while you're on the train, commuting to work or something like that. Or perhaps you have an intermittent internet connection, or you're on a yacht somewhere in the Bahamas. Whatever it happens to be, users of Bitcoin, users of BSV are going to have a difficult time broadcasting and keeping a maintained connection to all of those nodes to be able to send those messages to everyone. It's also the case that there is the peering logic in this network, which prioritizes certain nodes if they're seen to be block announcing nodes and things like that. So not every node is necessarily treated with the same amount of importance. There's also whitelisting within the node itself, which keeps track of nodes that are known to be important to it, for example, and we can sort of ensure that we never remove that node from the list of peers, or we sort of give it priority. Because there are a limited number of connections that any one machine can make in terms of inbound and outbound connections, different limits within the software itself, and just to networks generally. So with all of that considered, you can see this mobile client would have a much easier time just connecting to something that we would call a TX processing API. So a TX processing service. So it's a simple API, HTTPS web API. It's a request response model. Even if you have an intermittent connection, you can get one response from that, and you know that that service will continue broadcasting that transaction to the network until the status is mined effectively. So it handles all of the sort of fuzziness of a peer-to-peer network, so that you don't have to as a user. So that the desired outcome with this sort of thing is to ensure that developers can focus on their business specific problems, and they don't have to resolve problems that are essentially present in every business that uses a blockchain, a public blockchain that's distributed in the manner that Bitcoin is. Really dealing with that is the miner's role, and they're all competing to timestamp these transactions into blocks. As a user or a business using the network, we should not have to concern ourselves with that sort of thing. So that's why we want transaction processing services in general. And that's really just what I said there. So what is ARC specifically? So ARC is something that connects to, in an ideal world, connects to every mining node on the network. So it has some peering logic in there. It takes care of connecting to those other nodes on the network. It has some retry logic that keeps track of the status of a transaction that it is responsible for. It runs transaction validation. It exposes an API to clients, and it calculates Merkle paths for each transaction that it has broadcast. So if we jump into these microservices within the overall ARC system, we can take a look at some of the details there. So you can see in this diagram, on the left is the API server. There's a validator, and we can spin up multiple validators to take on more workload. Once validated, those transactions are pushed onto Metamorph, which is something that takes care of the changing transaction status over time. We store the transaction so that we can rebroadcast it to other peers if needed. We have a peer manager that takes care of all those connections. And at the bottom there, you can see we also store blocks in some format. So we don't actually store full blocks, but we store a new format of blocks, which is comprised of the TX IDs contained within a block rather than the full transaction data. So jumping into the API, this is what the users are interacting with. We have just a few endpoints. Really, we get a policy so that we understand this particular instance's requirements. Usually, the one that sticks out would be the bytes per satoshis per byte and the mining fee. So at the moment, that's really down to 1 satoshi per normal transaction. And if you're adding lots of data, then it's a calculation based on that satoshis per byte rate. But the main story here is that the TX submission endpoint is exposed, and the TXS endpoint is for arrays of transactions to process in parallel or serial. So each of these endpoints receives something called extended format transaction. So that allows this API and the validator, more specifically, to run script validation and check the fees paid by the transaction. So this is a fairly new concept. I think about 8 months ago, this concept was first suggested as a way to submit transactions to ARC. What it allows us to do is circumnavigate the potential bottleneck that would occur if we had to look up the UTXOs using only the raw transaction data. So a normal raw transaction only includes the TXID V out of each input. And that isn't enough information to calculate how much in terms of fees that transaction is spending or paying. And it isn't enough to understand whether or not the unlocking script will result in a true when paired with the locking script of the previous transaction. These bits of data are both available to the sender of the transaction usually, or at least let's say the person who signed the transaction has this information. And so what we're trying to encourage is for the originator of a transaction to pass this information to the recipient, who would then go on to broadcast it in this way. So the concept was developed in a way that expected a UTXO lookup to be available in the instance that was receiving this extended format. What would happen is the extended data along with the out point would be hashed, and that would be the key in a key value store that would look up the UTXO, ensuring that it was a legitimate UTXO that was being spent. So this is still in development, it's still in beta, so that is not actually available to us yet. The idea was we were going to take the UTXO lookup from Terranode and have a somewhat scaled down version of the same thing available within Arc. So that's one of the development paths that we have in front of us for a potential solution to that problem in future. And what that does is change this validation process from something that is somewhat performative to something that is genuinely checking that these transactions are valid prior to even broadcasting to the other peers. So that's an important point to make. So that's why we include the extended data, so we can do TX validation before we even get to Metamorph here. So the main goal of Metamorph is to take these pre-validated transactions and get them on-chain using the peer-to-peer network. So that involves potentially connecting to multiple metamorphs. Again, we wanted to make sure that the architecture was such that certain microservices like Metamorph were horizontally scalable. You can imagine if we're receiving millions of transactions, it starts to make sense to spin up multiple instances here and load balance between them. So as is detailed, I don't know if it's detailed on this slide actually, but it's a round robin load balancing operation that's used in this particular case. I don't think there's anything else to discuss here. Essentially, the Metamorph is responsible then for the transactions that it is handed by the API. And that's the service that would then pick up on status updates and forward them on. So the next microservice is BlockTX. Now this has undergone development even in the last week. So this is the service that again listens to the peer-to-peer messages, but specifically looks out for block announcements. When it hears a block announcement, it will go and grab the required data. And rather than just storing this data directly, it will actually actively process that data as it's coming in. So as a sort of service layer node rather than a core Bitcoin node of the network, because Arc is not assembling blocks itself, it doesn't need all of the transaction data at all. It doesn't need to validate these things. What it needs to do is make sure that the TX ID is really contained within the Merkle root, which is part of the block header. So what BlockTX does is, as the block data is streaming into the service, as each transaction comes in, that transaction is hashed, double shard, to get the TX ID, and we dump the rest of the data. So you can imagine that this creates a data structure that is just a block header and a list of TX IDs. That is how BlockTX is able to then calculate the Merkle path for each of the transaction IDs that the metamorphs connected are interested in. So each metamorph has its own subset of TX IDs that it's interested in. You can imagine that if there are 1 million transactions in a block, only a subset of those are of interest to the metamorph, specifically the ones that were submitted to it. So it will then update the status of the transactions it is responsible for to mind, and it will also store the Merkle path for each of those transactions. So that Merkle path is stored in a format that is described in BRC 71. You can take a look at that spec at brc.dev/71. This is an open repository. It's just a Git book that points to a repository. You're very welcome to submit your own ideas in future for improvements to formats surrounding Bitcoin. I encourage you to take a look at all the formats there. So we're going to take a look at the callbacker now. So If you were to hit, let's see, let's go back to the API here. If you were to hit the get TX and a TX ID, you can do this at any time. This is a way for you to just check up on the status as the TX progresses through the various stages, and we'll take a look at in detail what those are. But you can imagine that it might, rather than polling that endpoint, you might just want to sit back and wait for the transaction to be mined. So the callbacker is responsible for keeping track of who wants to be notified when a transaction status updates and for what particular status do they want to be notified. So there's a URL you can specify as well as a token if you so desire, so that the webhook can be fired across to you with the updated data, usually mined, and the Merkle path would be sent across to that URL that you provide. So it's exactly the same data as is included in the TX status is the point. So those are the 4 services. Let's take a look at the overall flow here. We're going to zoom into some of these pictures here, but on the left is the submit transaction flow. So on the far left, we have the client at the top. You can see that the API server runs the validation. And then we go through the metamorph system, finally arriving at the last status within a 5-second period. So I want to make clear that we, more often than not, all of these processes happen within a few seconds, and we do get a response that is 200 back from the API when we're submitting transactions. In unusual cases where there's very high spike in transactions per second on the network, there's a possibility that you would see a status of just announced. So I would consider anything like announced, sent, or seen as all positive responses effectively. As an application developer, you can choose what level of sort of certainty you want. And the default is for the response to timeout after 5 seconds, so that you'll get the most recent status after 5 seconds, even if you don't reach seen. If it reaches seen before then, which is most common, the status will respond, within a few seconds. So either it will update as seen, or 5 seconds will elapse and it will give you one of the other statuses. On the right here, you see the process block via P2P diagram. So this, as you can see, kind of goes in the other direction. The Bitcoin network is the initiating event. It announces a new block by announcing a block hash. And we go get that block, and we calculate the Merkle paths and deliver the TXID. We deliver the status update for TXID along with its Merkle path. So just jumping in so you can see this more clearly. Again, extended raw TX is delivered to the API. We go through a validation process. If we succeed, we just deliver a normal raw TX via gRPC to the metamorph. We register that TX with a store, and we get our first status, which is stored. As soon as we have done that process, we announce the TXID via the peer handler to the Bitcoin network, update our status to announced. Usually, more often than not, the Bitcoin nodes at the other Bitcoin nodes on the network will get the TXID data by sending a peer-to-peer message to us, at which point we can obviously pull the data from the store and deliver that to the corresponding peer. We update our status to sent. At that point, the data is sent. Once a node in the network has validated the transaction itself on receipt, it will announce that it has a valid transaction by sending an inv TXID message to all of its peers. So this is the way that this transaction propagates through the network. So when we hear that on the peer handler of Metamorph, we know that that transaction has seen the data that we sent it. And so we update the status to seen. And that is when we would respond on the API to the original client. So that's the usual flow. Again, just taking a closer look at the block hash message. So that one of the nodes on the network finds a block. We get that block data. We stream it in, strip out the transaction data, and just store the TX IDs and Merkle paths for each of the transactions we're interested in. In fact, that's not true. We do it for every transaction in a block at this stage. The reason we do that is in attempt to handle somebody submitting a transaction that's already been mined. So say you were offline and your wallet comes back online, you've gone through a tunnel or something on a train, you reconnect to the API, and you're able to see the status as mined, despite the fact that you never sent it. Somebody else did. So what that does require is all of the TX IDs in the block being stored by the block store. Yeah, I imagine the Merkle path calculation service to really become a little bit more sophisticated in future. This is really the first Merkle service that's separate from a node, just to be clear. So that's what differentiates it from previous iterations of the service in terms of Merkle proof delivery. It doesn't need the node to calculate. It has enough information to calculate those Merkle paths itself. So that's a key differentiator. So in general, we've had a lot of feedback from the ecosystem saying, isn't this just mAPI 2.0? And just to be clear, no, this was not the intention with ARC to just be mAPI 2.0. It's an entirely different approach. And although it's serving the same customers, we believe that this is the way forward in terms of being compatible with the likes of Terranode. So we'll jump into why that is just now. So this is an overview of a very, very stripped down basic understanding of what SV node is. So SV node is the official node implementation for the BSV blockchain. So it is responsible for assembling blocks, assembling transactions into blocks, validating those transactions, validating the blocks of other nodes on the network, timestamping, peer handling in terms of setting up the peer-to-peer network in the first place, all sorts of other things related to orchestrating hashing machines and so on and so forth. And also operating as a wallet. So there is a JSON RPC node wallet embedded in that software. And thinking back to when Bitcoin started, this makes a lot of sense that there would be functionality for normal users within the node software itself, because when things first started, it was just one bit of software that was doing everything, and you would use commands like send to address to send a transaction from the UTXOs that you have in your own wallet. And really what mAPI did, mAPI is an interesting sort of, I guess I would call it, what would I call it? It's sort of overloading this functionality of the original user wallet built into the node by exposing a public-facing TX processing API that would then in turn use the local node JSON RPC client to broadcast that transaction as if it were a transaction of the node itself. So this is a great solution in terms of the early days of dealing with this sort of fuzzy P2P network that was quite difficult for application builders to use. This made it much, much easier. So just like ARC, you submit to a standard web API and you're given a response that's signed by what is in effect a miner on the network and their node. It had some other functionality like double spend notifier, and it would send Merkle proof webhooks also. But these services would rely on that JSON RPC client with a node sitting right next to it. And the reason that's an issue, or the reason it became an issue, is over time, as the node started to run out of resources, as transactions got up to the millions or 100 million in a single day, the resource drain on the node itself Well, if you think about it, the node itself is prioritizing maintenance of the network. It needs to validate transactions that are coming over P2P, putting those into blocks. It's announcing its blocks, and it's competing with other nodes to be the best, fastest, most efficient in terms of assembling blocks and announcing them to the network and then hashing them. So with that in mind, it makes perfect sense that under heavy load, it would just ignore its local wallet JSON RPC client requests and just let them hang because that's not its priority. Its priority is to maintain the network. That's the sort of primary function of Node. So what that led to is, of course, this became unavailable to mAPI, which would get a 500 error from the JSON RPC client. And in turn, it would pass that 500 error onto the business or applications that were trying to use mAPI for broadcasting. So it became a bottleneck, in other words. So in high traffic, it becomes a bottleneck. And the reason that Arc doesn't have the same problem is because you can just spin up multiple metamorphs as demand increases. Yes, the network might be very busy. And yes, it might be some time before the network sort of arrives at consensus and puts those transactions into blocks. But in the meantime, the Arc is taking care of that status. So it could be sitting there as announced on network for hours, even if it's under very heavy load. Eventually, it will get mined into a block and it will update that status. So in other words, your application can move on and it doesn't have to run the retry logic itself. So it's separating you from the inherent fuzziness of the peer-to-peer network, whereas that's not something that mAPI provided people. So there's another reason we need to move to Arc, and that is that we're moving from SV node to Teranode in the next year. So as Teranode starts to come online, we're going to have to start thinking about how do we get transactions into Teranode. And there are some differences between the systems, as you would expect. And one of the major differences is that there is no wallet in Teranode. So you can't use the exact same functionality to get transactions into the network once Teranode sort of takes over the load from SV node. So that leaves us in a bit of a pickle if we're relying on mAPI. So this is part of the grander strategy where we separate and specialize out parts of the original software. You'll probably know me from working on the Light client over the recent years. So we're working on that software to handle SPV, and Teranode is separate. So Teranode is specializing in mining, assembling blocks, and validating transactions. Light client is focused on the user side of things, the utilization side. So this is separated out now. They have separate concerns, and that's why we can't just rely on the node wallet anymore. So again, going back to Arc, the difference is it's designed to broadcast to all nodes on the network simultaneously over the peer-to-peer network. We'll also have to consider, with Teranode in mind, using the IPv6 multicast broadcasting technique. Again, that's not something that's easy to do necessarily from every mobile environment. It depends on the router that you're connected to over Wi-Fi. Some of them will have IPv6 multicast turned on, some of them won't. But what we can rely on is people being able to make outbound connections to a transaction processing service, in this case Arc, which then handles all of the new fancy technology that's about hyperscale. IPv6 multicast is going to be easy from a hosted service like that. So again, you get a simple interface for mobile connectivity and transaction broadcasting. And all of the difficult stuff is removed from your concern, and you can just get on with building your business. That's the idea. So I think that's just a text version of what I was telling you there. The advantages, just to summarize though, transactions are broadcast over the peer-to-peer network. It avoids those bottlenecks associated with using the node wallet. Extended format transaction validation scales horizontally because it doesn't rely on the node itself. It doesn't rely on any external data. You just give it all the data it needs to validate. So we're stepping towards SPV. Metamorph provides a much more granular transaction propagation status. So rather than just getting maybe a 400 error or a 500 error or something, which oftentimes we were seeing in mAPI when things got busy, you'll actually get a sort of more information about where it is in the journey to becoming mined into a block. So for example, if it's just been announced, then you know, oh, there's high traffic on the network right now. It's going to be picked up eventually by the nodes, and you can keep checking the status to see how it goes, or you can register the callback URL to get notified as the status progresses. TX block provides that final status confirmation of mined and the Merkle paths so that you can build SPV payment protocols from the information you have. Or if you're just generating records, that's your one-to-one guarantee that this transaction is in fact in a block. You have as much information as you need. It's as good of a proof as having all of the block data and running a full node. But you don't have to pay $3,500 to $4,000 a month just to keep the thing running. And of course, the callbacker can inform you of asynchronous status updates. So those are the advantages of switching to Arc. So as Thomas announced at the start of the webinar, Arc is installed by both Tal and Gorillapool, the main miners on the network. You can take a look at the documentation specific to those implementations. I think I'm pretty sure it's exactly the same. As from a user perspective, Tal does require registration on their console to give you an API key. I don't think that Gorillapool require that at the moment. Though I think that's the only difference at the moment. But both of those miners are running things for a good couple of months now. We're in public beta, of course. So I would expect there to be challenges with respect to if you're using unusual transaction formats. There may still be some issues there. What we've been doing over the last couple of weeks is getting great feedback from some of our power users. David Case, shout out, has been finding bugs for us by generating some interesting transactions on chain. And we found some scaling limits in terms of just the software architecture itself. So I think topped out something like 3,000 transactions per second at the moment. So I believe that Tal are working on a particular Kubernetes config for their own instance, which will be able to handle more throughput. In terms of where we see this going from a sort of roadmap perspective, for the rest of this month, we expect to continue receiving feedback in terms of if we're producing any errors. Most of those errors, by the way, were associated with GoBT, which, and specifically the script interpreter, had some issues in terms of how it was dealing with unformatted op return data, which is used in script contracts to maintain state within UTXOs. So this was something that was just inherently flawed within the GoBT library. It was just it hadn't caught up yet with the developments within SV node that was introduced midway through this year to support unformatted transaction data after an op return, a final op return. So most of the issues were to do with that and have now been fixed, as far as I can tell. There are some remaining fuzzy things that we need to continue working on. We've assigned some budget to make sure that the GoBT script interpreter is very robust for all possible scripts. So we'll be introducing test vectors that will give us full coverage of what is possible in Bitcoin. And we aim to build that and then use that across all libraries that we develop open source from here on. So in terms of other developments, October to December, we're going to be phasing out mAPI come 2024. So essentially, we're not actively doing that. It's just a case of once we switch to Terranode, it's not going to be possible to use mAPI anymore. We're not going to adapt mAPI to use Terranode specifically. So basically, throughout 2024, we're going to encourage people to switch over to Arc, and eventually that will be deprecated, but a sort of soft deprecation. And we obviously you can reach out to Thomas and I if you want to have a meeting about that in terms of dates, in terms of it's not completely up to us, of course. We're just encouraging this. Really, it's up to the miners who run the software. But we're going to be encouraging people to move over to Arc. So next year forward, we're going to phase that out. We also expect that there will be somewhat of a divergence between the Arc, open source Arc, into really two products. One that will most likely be a very, very scalable Kubernetes configuration for Arc for miners to run and provide extra services that's going to develop. The other expectation is that there will be an independent business version of what Arc does just now that we would refer to as an overlay node. So there are many types of overlay node that you could build, but this could be one of them. So imagine that if you are one of the major companies in the BSV ecosystem, you want more control over the exact response you're getting from Arc. So you actually run your own instance of an overlay node, which is custom sort of developed into something that's more specific to your particular token needs, for example. Then we imagine that you can spin this up. What we're going to try and overcome is that peering logic issue so that you can just connect to the peer-to-peer network from your own instance without being a miner. That's certainly something that you can do very easily with Terranode. It's a little bit more difficult for SV Node at the moment, but nChain have come forward and said that that's something that we can probably figure out together. So we will be working on figuring that out together to make sure that it's possible with SV Node in the not so distant future. So you can imagine that you're running your own instance of this. It's not an expensive system to run yourself as a business. And that means that you can customize the behavior in terms of the API, how it deals with things. And really, it just becomes one of your services that is responsible for making sure that these transactions get on chain and in a particular order, yada, yada, yada. So whatever it is you need, you can build into your own overlay node. But we'll be producing a reference implementation for that self-service sort of overlay node, something that you can spin up yourself to look after your transactions for your business. So that is the future for Arc development. It's going to split up into those two products. I think we're going to take some questions at this time, but thank you very much for this first section. So taking a look at the comments here. Thanks, Richard, has sent one of the questions from Christoph. So how Arc will connect to the peer-to-peer network. So it as wallet part will be removed from Terranode. Terranode will have some specific protocol for Arc to communicate with network. Currently, it will still via JSON RPC. No, so Arc doesn't connect to the node network using JSON RPC, just to be clear. Arc communicates with the rest of the peer-to-peer network using the peer-to-peer protocol, so the Bitcoin peer-to-peer protocol, which is well-defined at the moment. And in terms of how that might change with Terranode, Terranode will have a module that communicates with the peer-to-peer protocol as is, but we imagine that it will be more efficient to receive transactions simply by exposing a bunch of IPv6 multicast group addresses in sub mode for the nodes. They would subscribe to particular multicast group addresses. And then any user on the network could just, and this is how Arc would do it, it would transmit the transaction data to the multicast group address by publishing to it. So that's pretty new as a concept within the Bitcoin space, but this is something that the guys working on Terranode are working towards. So it's much more efficient in terms of making sure that all of the nodes get the transactions at the same time. Also allows you to do cool things like anycast to get transactions that you may have missed and things like that. So yes, we'll be developing a module within Arc to deal with the IPv6 broadcasting side of things. But we're very early stage with that stuff. And we're just going to be reusing components that are built by the Terranode team, build that into Arc. Kumar is asking, is this valid upon a particular web and e-commerce? So yes, you could use this with web apps. You can use this in e-commerce solutions. Absolutely. It's from the user side, it's simply an endpoint you can submit transactions to, and within 5 seconds maximum, it will give you a response as to whether that transaction is valid or not, as far as the service is concerned. Simple. Bernard Mueller is asking, background of questions is acceptance of several transactions for a payment settlement. Can ARC be used to only check if a TX would be accepted into the mempool if it were broadcasted, but without actually broadcasting? Hey, that's a great question. No, ARC cannot be used for that at this stage. If you send it a valid transaction, it will broadcast it, and if you send it an invalid one, it won't. But that's a cool feature request. Perhaps that could be something that we would expose if that's something you would like. It certainly wouldn't be difficult to do that because they're a separate service. So perhaps we could add a particular header that suggests that it should not actually broadcast, just what would you call it? Trial run or something like that header. Yeah, we could do that. Okay, so or does it allow to broadcast batches of TXs and only actually have them mined if all of them are valid and not mined if one was not valid? Okay, so interesting. So you're looking for atomicity with a set of transactions. So I believe that may actually be the case with, okay, so 2 responses to this. So I think that's what the validator does when you send a transaction, a set of transactions to the TXS endpoint. I would need to check with the developers that is in fact the behavior, but I think it is. But the second point being that's actually something I see as possible with a new format that is being proposed called BEEF, which is Background Evaluated Extended Format. So that would allow you to include a set of raw TXs and the Merkle paths for any that have been mined, and be able to send that as one blob, binary blob, and have the counterparty validate that, just like you're suggesting, as a whole set prior to then passing them individually onto the network as transactions to include. So perhaps that's the solution in that case, if it's not already implemented.
Yeah, I think there is another one from Christophe. So this whole infrastructure behind ARC, like all those microservices, is independent deployable unit which connect to network to grab data and can be deployed by anyone.
Yes. Yeah. So rather, the ARC API is probably like the base service. So ARC API is the base service, and then with the configuration, you can say, I want to spin this up with Metamorph or with multiple Metamorphs, and you can spin it up with BlockTX as a service and with Callbacker as a service. So that's where it starts. It starts with the API, and then you can spin up instances of the other microservices independently. And so the second half of that question was who deploys that whitelisted. So just to be clear, so when we first started the project, the idea was, or I think it's one of those things, everyone has a slightly different idea, but in my head, at least from the utilization side, the part of the plan was to allow any business to spin this up. So an example of a business might be tokenized or hand cash, say, big businesses in the ecosystem. So imagine that they're having problems with their transaction processing API today. Well, then you give them the option to run their own in-house, which connects to the P2P network and broadcast transactions on their behalf and is sort of managed internally to that company. So that was the goal. When it came to actually implementing, the developers found that it was really difficult to maintain a peer-to-peer connection to the relevant nodes to have a consistent transaction processing API hosted anywhere in the world independently. And so to get over that hurdle and to get more feedback earlier on in the development of this product, we took it to beta, private beta first, and we ran ARC from Gorilla Pool, from Tal, and we specified a config that allowed ARC to connect to one peer rather than all peers, and that peer was the local SV node. So I know it seems ridiculous in terms of you're using a peer-to-peer network, but you're only connecting to one peer. But the fact of the matter is that that was the only way we could make it a really reliable service at this early stage of development. So why exactly it needs to be whitelisted, as in Arc needs to be whitelisted by the SV node that's it's connected to. For example, so that it never gets kicked. So you can imagine that Arc could be sent a transaction that isn't valid. If there's something wrong with the validator in early development, for example, the UTXO that is sent with the EF data, it doesn't actually exist. The validator would think it exists and would validate it and then broadcast the transaction to the network and immediately get banned by all the peers who can detect that that is not a valid UTXO. So for reasons like that, these early instances of Arc are being whitelisted. I think that hypothetically, if you were to run the software, I think it would actually work, but it's just that it would be inconsistent. And that's obviously not something that we would advocate for now. We're still working on making sure that that connection is much more consistent. And partly it's a case of we have a limited budget. We don't want to invest in something when we're expecting Terranode to come along and replace this. And so it's a question of how urgently do we want to get this done. If we can get it done now, fantastic, we can figure it out and we'd advocate for that. But at the moment, we can't in good conscience advocate for that because it's been inconsistent during development.
Good. There is one last question. I think we are a little bit over time, but from Samir, it's indeed noteworthy that a business application can establish its own instance of overlay node within Terranode. This development raises the question of whether it will be effectively address the incentives required to encourage broader participation in supporting the application through instance operation.
Yeah, it's a good point, Samir. Definitely, it will lead to a more distributed ecosystem, I think, and it allows more specialization. So, for example, Gorilla Pool comes to mind as a miner that's more focused on sort of an ecosystem of sort of entrepreneurial, quick builds. Let's just get it up and running as soon as possible kind of ecosystem. That's probably more the ecosystem that would be interested in running their own overlay node, dealing with their own broadcast fuzziness with their own instance. So yeah, definitely. I'd encourage you to look into it. Please, if you're doing that, please get in contact because I'm interested to see what your experience is like in terms of spinning it up yourself without being a miner. And hopefully that way it will speed up the development curve of figuring out why it's inconsistent and what we might need to do on the SV node side to deal with that in the short term. Because yeah, I think that would be an interesting development.
Good. I think that was the last question, and we are a little bit over time, so we might end the webinar now. Thank you all for your questions. Thank you, Darren, for these great explanations. You have also the ability to interact with us on the different Discord channels. On the BSV blockchain side, we open an Arc Discord channel to make sure that if you guys have any questions, feedbacks, feature requests, don't hesitate to provide us with your feedback there. And then the different miners have their own Discord channel, so you can also, from a more operational perspective, provide the different feedbacks to Tal and Gorilla Pool within their own Discord channel. And then we're gonna try to handle this kind of webinar as frequently as possible to make sure that we increase transparency within the ecosystem and we are able to answer any questions. Darren, if you were to finish the webinar.
Yeah, thank you so much, Thomas, for hosting and helping me out here. Yeah, thanks for those who participated and sent those questions. And I'm also available on Twitter, just /Dagan. Happy to answer any questions directly there also.
Thank you all. Have a great day. Bye-bye.
Thanks, everyone.